In this presentation, we will discuss what are quantifiers and we will also see some examples related to quantifiers. So let's get started. Here is the definition of quantifiers. Quantifiers are words that refer to quantities such as sum or all. It tells for how many elements a given predicate is true. So it basically tells for how many elements a given predicate is true. If a predicate is given to us, we can identify for how many elements a given predicate is true with the help of quantifiers. Now in English, if I say, quantifiers are used to express the quantities without giving an exact number. For example, here we will use this all, some, many, none, few instead of using the exact numbers. We could have sentences like, can I have some water? Jack has many friends here. You can see in these type of sentences, we are not using the exact numbers. We are not saying how many friends does Jack has, right? Jack has many friends here. Instead of saying 2 friends, 3 friends or 4 friends, we are saying Jack has many friends. So these are called quantifiers. We are quantifying the statement in a different way. Instead of using exact numbers, we are using these words. All, some, many, none, few. In mathematics also, we will use these quantifiers, and you can see these are very important when we are considering predicate logic. They are helpful in telling us for how many elements a particular predicate is true, a particular sentence is true. Let's consider the different types of quantifiers here. The first type is universal quantifier and the second type is existential quantifier. Now let's consider one example which helps us to understand how quantifiers works in mathematics. Here is an example. In this example, we have to let that Px be a statement x plus 1 greater than x. I would like to ask one question. What is the truth value for P1? P1 will be definitely 1 plus 1 greater than x. Or I can replace this x by 1. Then this will be equal to 2 greater than 1 and this is true. So 2 is greater than 1 and that is why the truth value of P1 will be true. What will be the truth value for P2? P2 will be 2 plus 1 greater than 2, which is finally equal to 3 greater than 2. And yes, this is also true. And this continues in the same way, right? Actually, it is true for all positive integers, let me tell you. Px is true for all positive integers x. This should be well noted that whatever the positive integer you will take, Px will always be true. So I can say that Px is true for all positive integers x. Or in other words, I can say for all x Px. This is another way of saying this sentence. This particular notation is called for all. Okay, this is the quantifier we are talking about. We will use this quantifier to denote that Px is true for all positive integers x. Here x represents positive integers, Px is our predicate and this notation is called for all. Okay, we will use this notation. This represents for all. So we'll put this in front of this x Px and we can read this as for all x or for all positive integers x, Px is true. I'm repeating this once again. For all positive integers x, Px is true. Now let's consider one more example. Let Qx be the statement x less than 2. Let's do the same procedure once again. What is the truth value for Q1? I would like to ask this question again. What is the truth value for Q1? 1 is less than 2, right? So definitely this is true. But if I ask what is the truth value for Q2, then you will say this is false. 2 is not less than 2. This is false. And if you take Q3, Q4, Q5 and so on, for all of them this will be false. This will only be true for this Q1. And for the rest of the positive integers this will be false. So my question is there some value of x for which Qx is true? If domain is a set of positive integers, I am considering the domain as set of positive integers. And here my question is there some value of x for which Qx is true? Yes, of course, there is some value. Qx is true for x equal to 1. We have seen that for x equal to 1, Qx is true. Therefore, there is an x for which Qx is true. Or I can say that there exists some x for which Qx is true. This is the way I represent there exists x Qx. This is also a quantifier and actually it represents there exists. And if I read this, then it will be read as there exists some x for which Qx is true. And obviously the domain is considered as set of positive integers. Okay, so there exists some x for which Qx is true. This is how you read this. Okay,